All right, welcome.
One of the most powerful ideas in all of programming is not really about writing super complex code. It's actually about writing less code. It's all about getting the computer to do the boring, repetitive stuff for you. And trust me, once you really get this one concept, you're going to understand what makes software so incredibly powerful.
So, let's start with a big question you'll hear all the time in the software world. Why do programmers seem to hate repeating themselves so much? It's a classic saying, right? But get this, it's not about laziness, not at all. It's actually a core principle, one that's all about being efficient, powerful, and building things that can actually scale up. To really, truly appreciate the solution here, we first got to understand the problem we're trying to solve. So let's just call it the repetition problem. And believe me, it's something every single new programmer runs into. So imagine this. You need to print the word hi on the screen. Simple enough, right? That's just one line of code. But what if you need to print it 4 times? Well, the most obvious, basic way to do that is to just copy and paste that line. I mean, it works, but doesn't it feel a little clumsy, a little awkward? It feels clumsy because, honestly, it is. This whole copy-paste thing is super inefficient. I mean, what if you needed to print hi 100 times or 1,000? You're not just making more work for yourself right now, you're creating code that is an absolute nightmare to update later. Imagine you wanted to change hi to hello. You'd have to go and edit every single line. It just doesn't scale. There's a perfect analogy for this. Think about it. Manually repeating code like that is like being a kid in school getting told by the teacher to write the same sentence on the blackboard 100 times as punishment. It is exactly that kind of tedious, mind-numbing work that computers were literally invented to get rid of for us. Okay, so how do programmers get out of this digital punishment? Well, they use this really elegant and powerful solution that was designed for this exact problem. It's a concept called a loop. And this right here is one of the most fundamental building blocks in all of programming. And this right here, this is the aha moment. It shows it perfectly. On the left, you've got that manual, repetitive code. But on the right, that's the programmer's way of thinking. Instead of writing the line 4 times, we write it just once. And then we tell the computer, hey, just repeat this instruction 4 times for me. So much cleaner. And that brings us to the more, formal definition. So what is a loop? It's a programming structure that repeats a sequence of instructions. That's the what to do part. And it keeps doing it until a specific condition is met. That's the when to stop part. It's the absolute foundation for automating anything repetitive in your code. Okay, so once you really embrace this powerful idea, you start to see that it's not just a single tool. It's more like a whole toolkit. So let's take a quick tour of the most common types of loops you're going to run into as a programmer. In a ton of popular languages, think Java, Python, JavaScript, you're mostly going to be working with a few key types. The 3 big ones are the while loop, the do-while loop, and the for loop. Now, they all do the same basic job, repetition, but each one has its own special strength. And this is the key takeaway here. You don't just pick one of these loops at random. Each one is a specialized tool for a different job. Knowing which one to grab for a specific task, that's a huge skill for any developer. Some are great for when you know exactly how many times you want to repeat something, while others are perfect for when you need to keep going based on some condition that might change. So this whole idea of choosing the right tool leads us neatly into 2 main categories of repetition. Just about any repetitive task you can think of is going to fall into one of 2 buckets, finite or conditional. And getting the difference between these 2 is absolutely key. This table lays it out perfectly. First, you've got finite repetition. This is when you know the exact number of times you need to do something. For example, printing a message 100 times. Then there's conditional repetition. This is when you don't know how many times you'll have to run the loop. You just know that it should keep going until some condition changes, like a program that keeps running until a user finally presses a key. And yeah, you guessed it, different types of loops are built specifically for each of these situations. All right, let's bring this all together. Why is this whole concept not just some handy trick, but an absolute non-negotiable necessity for any programmer? What's the really big idea here? It's because loops are basically the engine of automation in all software. Think about it. They transform a programmer from someone doing manual labor into an architect who designs systems. You're not laying the bricks one by one. You're designing the machine that lays all the bricks for you. Every single time you scroll through a social media feed or you play a video game or search a database,
There are loops working behind the scenes, performing billions, literally billions, of operations that would be completely impossible for any human to do by hand. And that, right there, is the real magic. You, the programmer, you write one small, smart little block of code. The computer then takes that one single block and can run it 5 times, 1,000,000 times, or, yeah, even billions of times. It's the ultimate form of leverage in the digital world. So I'll leave you with this question to chew on. We all have those tedious, repetitive tasks in our daily lives, right? So now that you understand the core idea of how to automate them, what's the very first task you'd want to just hand over to a loop and never do again yourself? Think about it.